Chapter 7 test review. Chapter 7 test review. Number 1 says state if the polygons are similar. This takes us way back to the first thing I taught you. It was that group jam day. Okay? If the polygons are similar, we have to check two things. What's the first thing? Angles. Are the angles, I'm going to call this 1 and 2. Are the angles matched up? Yes. What's nice about this one, they're all 90-degree angles. Okay? What's the second thing we check? The side ratios. So, for example, if I start with 15, what am I comparing 15 to?
20.
15 over 20. I need to reduce this. What can I reduce that by?
5.
Divide both these by 5 to get 3 over 4. Okay, what do I need to do next?
The sides.
I need to check another one. What's another one?
12 over 8.
Right. Does the order matter?
Yeah.
Right. Can I do 8 over 12? No, it's got to be the same order. Divide both these by 4 to get 3 over 2. 3 over 2.
Same box.
Yes.
If you do 15 and 20, then you have to do 12.
Yep. Do I need to check any more? Why not? Right, because they're all the same. So if I checked these, I would get the same exact thing. So what does this tell us here? Since the ratios are different. Not similar. So your answer is no. Not similar. If they were the same, then your answer would be yes. And make sure you are checking all the ratios that you need to. In this case, we only need to check 2 because the others were the same. Okay. Number 2, it tells us, directions are very important. It tells us the polygons are similar. What does that mean if they're similar? The ratios are the same. Okay, so we know the ratios are the same. That allows us to find our scale factor. Underline that right over here. Scale factor, all I'm trying to find is the ratio. Okay, so when it's looking for the scale factor, I just want to know what the ratio is. Okay. Another big thing to make sure you do it in the right order. It wants smaller to larger. So which one's the smaller one, right or left?
Right.
Right's smallest. This is larger. So the ratio or the scale factor that it wants is it wants smallest to largest. So make sure you're writing it in that order. What's a ratio I can create?
24.
I could do 24 over 32, or I could do 18 over 24. Either one, you will get the same answer because all ratios are the same. So if I do 24 over 32, what can I divide both these by?
4.
Go higher. Yep, 8, which is 3 over 4. That right there is my scale factor. If you did 18 over 24, you would get the same answer. Bless you.
So,
Number 3, again, it tells us the polygons are similar. So we know what? Ratios are the same. So I'm finding a missing side. What are we going to set up? Starts with P.
The fish thing.
Proportion. Okay, we're going to set up a proportion. If I start with X, what does X relate to?
40.
X relates to 40 equals, what's another ratio? I could do 9 over 15, or I could do 21 over 35. Yep. So here we cross multiply 15 times X, 15X, 40 times 9, 360. Divide both by 15. We get X equals 24. Okay. On your test, just like all your worksheets, I need to see 2 things on each problem. I need to see your proportion, and I need to see your answer. Okay? I care more about your proportion than I care about your answer. Okay? Because this proportion is the main thing that we learned this chapter. Okay? So, just like all your worksheets, show the proportion and show your answer to get full credit. Capiche? All right. Number 4, your 1 multiple choice. What conclusion does the diagram support? So it's asking what is true, and there's only one that's true. Keep in mind, all of these are parallel. That's going to help us. Okay, so I'm going to go through each one of these. AF is half of CD. True or false? That's already false because CD is already smaller, so that doesn't make sense. BE equals half of CD. Again, that doesn't make sense either because CD is already smaller. C, AB over BC equals FE over ED. That is true, right? That's our side splitter theorem that we talked about. That's the one we use the most, especially with parallel lines. And then this last one, just to double check, it says BE over CD equals AF over BE. There's nothing we talked about that relates to that, so D is not our option either. Okay. Not chapter. Number 5. We want to find the side LM. Okay. What kind of triangles are we dealing with right now? With the angles, we're dealing with right triangles, okay? So this is when we talked about geometric mean, okay? What's the geometric mean formula? Yep. A over x equals x over b. I want to talk about this formula real quick, okay? These x's right here, does that mean that's where the x value goes? No, what does that mean?
The number that's on the shared side.
It's the number that's the shared. It could be the altitude, okay? Or it could be one of the two legs. Okay, so it's the number that, it's the side length that is involved in both triangles that you're comparing. Okay, so if I'm looking at my diagram here, which value, 12x or 16, is a part of both? It is 12, right? And 12 is our altitude. Remember the trick I told you? It is never going to be any part of your longest hypotenuse. Okay, it's never going to be that. It's always going to be one of your 3 legs or the altitude. Okay, so 12 is my like side. And then what do I pick for A and B in my formula? It's what's left, right? Because in this small triangle, 12 relates to x. And then in this triangle over here, 12 relates to 16. So now I cross multiply here. I get 16x equals 144. So we get x equals 9. Again, this is kind of a 2-part question. So when you find a value of something, what should you do with it? Put it in the picture because it's probably going to help you later on. Okay, so I know now that LM is 9. Moving on to number 6, it wants to find KJ. Now there's a couple different ways you can do this. I'm going to go through both. What's one way you could do it? Pythagorean theorem. Yep, let's go through that one first. What is the Pythagorean theorem? Exactly. We didn't talk about this much, but I know a lot of us know how to use it. First thing you want to figure out is the C value. So if I'm looking at this right triangle right here, what's my C value? Careful. Why x? It's the longest side and it's across from that right angle. Okay, so I know my C has to be x, and then my A and B is 12 and 16. So I have 12 squared plus 16 squared. 12 squared, 144, 16 squared, 256. So now it's just a matter of evaluating. Add those two together. I get 400. Last step here. Yep, don't forget about that square there. Square root both sides. We get x equals 20. Okay, so that's one way you could do it, Pythagorean theorem. What's the other way? Right, you can do geometric mean all over again. What might make the geometric mean tricky this time is we might have to find some extra values. Okay, so which one is if I'm looking for x here, which one's the shared value? X, right? Because it's a part of this triangle and it's a part of the major triangle. So I agree with you. X is my special value this time. Okay. In this triangle, what does x relate to? Remember, it's always going to be a part of this hypotenuse. What's it relate to? 16.
And then you add 9.
Yep, and then the whole thing, what does it relate to?
25.
Yep, I got to add this whole hypotenuse together. So that would be 25. Setting this up, cross multiply. We have x squared equals 400. Last step, square root x equals 20. So notice you get the same answers. I do not care how you do it. Okay, you can choose up to that point which method you like better. Okay. Number 7. Again, we're working with a right triangle. So what formula am I going to use? The geometric mean. Yep, a over x equals x over b. Again, keep in mind those x's, that's the what?
The shared side.
That's the shared side. Yep. So if I want to find x here, just to reference this again, what does it mean when it has this line?
The whole.
That's the whole length, right? Yep, if I had a line here, that's the whole side. So which value is a part of both triangles? I agree, because 60 is a part of the smaller one, and 60 is a part of the larger one. And again, it's always going to be one of these three sides. Okay, so 60 is our shared value. What do I put in the others?
36 and X.
Yep, because 36 is a part of the smaller one, and X is a part of our larger one. So now cross multiply here. We get 36X equals 3,600. Last step. Yep. Divide by 36, X equals 100. Again, once you find something and you have another problem, what should you do? Put it in your picture. So I know this is 100. Okay. Number 8, we want to find the altitude. First of all, we have to figure out which one the altitude is. Yep, it's the one that's going down the middle. Yep, this is your altitude. Again, we have one of two ways. We can do Pythagorean theorem again, or we can do the geometric mean. Okay, let's just go through both. I'm going to show you Pythagorean theorem first. Okay, so if I use Pythagorean theorem, let's look at this right triangle right here. Because the reason I picked this triangle is because I want to know at least two of the side lengths to help me out. Okay, so which of those is going to be my C value? Remember, C is our longest side. 60, again, because it's across from that right angle. So this turns into 60 squared. And then my A and B are 36 and X. Yep, so I have 36 squared plus X squared. 36 squared is 1,296 plus X squared equals 3,600. How do I solve from here?
Subtract by 1, 2.
Yep. Subtract 1,296. So I get X squared equals 2,304. Last step. Yep, take the square root. So we get X equals 48. So you can use Pythagorean theorem, or again, you can do geometric mean. So let me erase what I have here. If I want to find this with geometric mean, we have to figure out what our shared value is. What's our common value?
60. Oh, 6.
I agree with 60, but we're looking for X, so we want our altitude to be that shared value. So we want X in our shared value. Now the tricky part is we want to figure out what we put and what's left. Okay, if I'm looking at this triangle, what relates to X that's a part of the big hypotenuse? 36. And then if I'm comparing this triangle over here, where do you get 64 from?
100 by 36.
Right, we want to find this number right here, so I need to take 100 minus 36 to get 64. So that is our side length that needs to go there. So if we cross multiply, we get X squared equals 2,304. Last step, square root, we get X equals 48. Again, I do not care how you do it. For today. Number 9, finding the missing side length. So I'm looking for this one right here. What's nice about this diagram? What kind of makes this one a little easier? The parallel, right? Remember what you kind of did that on purpose. What we talked about on number 4 here, that side splitter theorem when we have parallel lines. Okay, so if I come back to this diagram over here, if I start with X, again, I always recommend you start with the algebra to give you a starting point, okay, because that's what you're actually looking for. So, what can I relate X to?
9.
I agree with everything that was just said. I heard X is not X over 9 and X over 2. I agree with both of those. If I continue with the X over 9, what does the other side have to be? 2 over 6. If I continue with X over 2, what does the other side have to be? Has to be 9 over 6. Both of these are correct, because if I cross multiply both of these, I'm going to get 6x equals 18 for both of those. So then last step, divide by 6, x equals 3. Okay, any questions over this front side here?